Hello everyone, and welcome to the Efficient Neighbor-Friendly Sports Lighting webcast. My name is Samuli Saransalmi, Product Marketing Manager at LEDiL, and I will be your host for today. In this webcast, LEDiL's very own lighting guru, Tero Makinen, will guide you through best practices to achieve good sports lighting that is pleasant for spectators and players alike, without forgetting the surrounding environment. In sports lighting, good design equals good lighting. Learn how LEDiL game-changing low-glare optics allow optimal lighting conditions for both players and spectators, while meeting the standards and requirements of different sports. During the webcast, you can send your questions and Tero will try to answer them at the end. So without any more from me, here's Tero.
Thank you, Samuli. And hello, everybody, also from my side. And like Samuli mentioned, today's topic we are discussing about the sports lighting. Let's start first with a little bit on the more general level before we make a deep dive into the fantastic sports lighting optics that we have just released. But I thought the best way to put everything in the context and give a little bit like a guideline of where we are following is to look into one of the FIFA guidelines. And FIFA, the World Football Association, is defining sports lighting as, and this is straight from their guidelines, it's a lighting system which meets the need of the broadcasters, spectators, players and officials without spilling light into the environment and without creating a nuisance for the local community. And this is a pretty large goal to hit and cover if we think that we need to master a lighting which is something for which has to meet the requirements of many different kind of stakeholders. If we think about the broadcasters, they definitely have very much different requirements on the lighting compared to the spectators or players. And then we have local community, which of course always is concerned about the nighttime glare and the nuisance light. And if we try to meet all of this, we need pretty special lighting. If you look at the good sports lighting a little bit more in detail, there's a couple of different tasks that the good sports lighting, regardless of the venue, whether it's indoor, outdoor, regardless of the sports that they are playing, it always has to ensure the optimal playability. It has to adapt into different requirements of different kind of sports, depending on the, for example, speed of the gameplay. The lighting requirements can be quite drastically different. Good sports lighting also has to be safe and pleasing for players and spectators. This puts a lot of emphasis on the things like shadowing, flicker, uniformity, also the basic level of light which has to be adapted into gameplay. And good sports lighting helps to avoid nuisance lights, which means in this case spill light and light pollution to the environment. And for the venue owners, good sports lighting, of course, provides the lowest cost of ownership. It's optimized for the lifetime. And naturally, everything has to comply with the standards and regulations, of which in sports lighting, there's quite a few. Basically, for every different type of sports, they have their own. And it also has to save energy. And nowadays, this seems to be quite important in many ways. Not only it's saving the cost of the ownership for the venue owners, but it also makes sports lighting more acceptable in the heads of the people who think that money spent on this kind of amusements could be used for many other things. So it makes it more acceptable. And sports differ a lot. We have many different kinds of places. For example, racing circuit, football stadium, even a slalom slope. They all can be artificially lit. And if you think about lighting requirements for these three different venues, the requirements could be pretty drastically different from each other, but they do have some things in common. They do have things in common that all of these places are starting to have more or less artificial sports lighting. And these basic rules, they apply into all of these. So there are few common things how sports lighting is different from the general lighting, for example. First of all, it's three-dimensional. We are not illuminating any horizontal areas anymore. We are illuminating a volume of gameplay, and we must ensure that whatever are the requirements, the entire volume of gameplay is perfectly illuminated to ensure the optimum playability. Sports lighting must be spatially uniform, and it must be avoiding shadows. In architectural lighting, shadows can be used as a way to emphasize things and make them more visible. In sports lighting, if you have lots of shadowing in many, for example, fast-paced board games, you can easily create a lighting which is totally impossible to have a good gameplay. If you're illuminating a football field with bad uniformity and lots of drastic shadows, it can create all kinds of weird effects where the ball may be moving faster than it actually is, or sometimes it gets slower, and that makes it very difficult for the football players to actually have any kind of good gameplay. And sports lighting, usually, because we are illuminating large areas, large spaces, it must be bright, but it also has to be not only glare, it has to be less low glare by itself, but quite many cases sports lighting can be also used to reduce glare in many setups. So even these drastically different from each other venues that we have here, they all follow these same rules. And then if we look at a little bit more in detail, we need to start dividing things into a smaller application fields. Let's start with the indoor sports lighting, where, as we can imagine, most of these venues, they don't have many windows, so artificial lighting is absolutely needed for consistent and adequate lighting levels. And also safe conditions, we need to have adequate illuminance levels to ensure the safe gameplay. And quite many cases, especially nowadays, we are seeing more and more venues where the indoor sports lighting will be a combination of artificial lighting and daylight. And in these cases, the artificial indoor lighting has to be adopting into levels of daylight, and you need to have some quite fancy control systems. However, these are getting more and more popular. And the role of the indoor sports lighting is, to summarize, is to create a pleasant and very nice experience for the spectators, increased usable hours of these venues, etc., etc. Then, on the other hand, outdoor sports lighting, where different from indoor sports lighting, the artificial lighting is not necessarily needed because we have that one huge sports lighting luminaire up in the sky with the perfect color rendition index and absolutely no flicker at all. But the problem, so I guess most of you guessed already, I'm talking about the sun. But the problem with the sunlight is that it has quite limited availability. It's not available in the evening time or during a night time, unless it's summer and you happen to live in Finland, but which is not applying to many people globally. So we are seeing a lot of outdoor sports lighting installations where also the artificial lighting is first of all ensuring that there is adequate and uniform levels of light regardless of weather. This is absolutely important for any televised sports, and we are seeing more and more televised sports happening all the time. It's also ensuring that there is always an optimized gameplay conditions regardless of the sports that there is happening. And outdoor sports lighting is necessary for televised sports events in order to avoid harsh contrast, to avoid excessive shadowing, for example, etc. For the venue owners, and this is one of the biggest drivers we have for outdoor sports lighting right now, is that artificial lighting in the outdoors that extends the hours of play. And this has become very important aspect in the outdoor sports lighting. Back in the days, life was much more simple and less hectic. People left their work in the afternoon, and then you had plenty of time to go out, play some football with your friends, and then you go to home, have dinner, etc., etc. In the 20th century, the 21st century, the life has changed in a lot more hectic, and more people are working late, and we have a need to if we are going to have any or play any sports, quite often we have time to play sports only in the evening time or night time when the sun is already pretty low or it's complete darkness, and there we need outdoor sports lighting, and this has created a demand for the sports lighting. And of course the venue owners, they like the idea that they have more hours that they can sell to their customers. So regardless of indoor outdoor, a great sports lighting design takes into account many different things. When we are designing for sports lighting, when we are designing illumination for sports facilities, there are many different things we need to take into account, regardless of indoor, whether it's indoor or outdoor. We have to think about the layout and size of the sporting venue, not only the field that we are illuminating, but also the adjacent fields. And therefore we have to take into account the layout of the field of play. This is extremely important in many cases where we have multi-sports facilities, multi-use games areas, that kind of places. And when we have adjacent fields, we also have to consider the connecting areas. We have to make sure that the lighting for the one field is not introducing glare into the one next to it. Also the lighting requirements, we have to design for the proper use. If we are talking about the small communal practice field where our local team goes to play football once in a week, it doesn't make sense to design their stadium class illumination. although it would be very fun for that one team, but it's still not cost effective. For pretty much same reason, we have to consider always the nuisance light. We have to make sure that we are not overlighting the venue, but we are still providing adequate light, etc., etc. There's quite a lot of different requirements, and sometimes we can have conflicting requirements, especially in the indoors. For example, where we almost must ensure that we have adequate lighting levels. And this can be sometimes difficult if we have mixed daylight and artificial light. We may have to have a lighting which can be or is actively adjusting based on the level of the daylight. We have to consider luminaire positions. Although the illuminated areas in the indoor sports lighting venues are smaller than outdoors, we still need to cover quite large areas with quite high illuminance levels. If you look at the volleyball requirements, we have average lux of 750 lux in the field. And that means that we need to have quite significant amount of light, and therefore we must consider both luminaire positions and light directions very carefully. And one thing which is very difficult, very different from general lighting is how in the sports lighting requirements, we almost always must also take into account a vertical illuminance. Even in the requirements where the technical requirements are just defining the average horizontal illuminance and uniformity requirements, which is very typical for most of these, for many of the requirements, there still is a certain requirement for vertical uniformity. And we must ensure that we are also having low enough contrast so that we are not creating any confusion for the players, such as, for example, the one last picture on the right is a very good example of bad sports lighting, where half of the players are in full light and the other half is completely dark, and you cannot see the shape of the player, you cannot see the movements of the player or directions where they are moving very clearly, and in worst case this can be downright dangerous. And then to make things even more interesting, especially in indoor, we have lots of these multi-use areas where sometimes the lighting can get very crazy. We think about badminton, we have a field of play which has to be illuminated from the center line, and it has to be illuminated to quite high, great heights compared to the size of the gameplay area. So we have almost a full, like 1x1x2 cube that we have to illuminate, but we can also only use luminaires in the middle. And quite often we see these, we don't see lots of dedicated badminton halls, or quite often we see these placed in the multi-use areas where you have your badminton fields, you have your basketball field in the same space. And basketball fields, they have quite funny requirement that there is a 5 meter, there cannot be any luminaires positioned above the basket in the 5 meter distance. So let's say a typical use case, we have 3 of these badminton cases side by side, and then we have a basketball field designed for the same space. Guess where the badminton field luminaires are going to be? They are straight above the basketball basket, which is not possible. But with the right type of optics, good lighting design, we can still solve these things by having perhaps sometimes some of the luminaires, they can be moving and they are dedicated for certain sports being played in that venue, while other luminaires can be general. And therefore, with the right type of optics, we can solve these otherwise pretty much impossible cases where you cannot meet the requirements of all of the different gameplays. So here's an example of that multi-purpose indoor sports facility, which is designed for the basketball, badminton, and volleyball. And you can see how basketball and volleyball, we are able to use pretty much the same luminaire setup. And then for the badminton, we have some of the luminaires different, helping to optimize the lighting requirements for each of the sports. Yet we are still using just 2 different types of luminaires, and there is not too many excessive dedicated luminaires per sport, and we are capable of meeting the requirements. Then in the outdoor sports lighting, the requirements depend on many different cases. There are quite many usage areas. All of us are thinking about football or soccer, depending where you are from. But we have lots of different places where, or lots of different outdoor venues which are being illuminated by, which have artificial illumination. Not only football, but in many cities we have lots of multi-use games areas. These are getting more and more popular, and these are the ones where the benefits of having extended usage hours are the biggest. We have tennis courts, we have athletics tracks, we have golf driving ranges. That's a huge market for outdoor sports lighting. But we also do have alpine slalom slopes. We have motor racing circuits, skate parks, etc., etc. So the outdoor sports lighting is also a lot more diverse lighting application area than the typical football and soccer that we are quite easily assuming. And things which are driving the artificial outdoor lighting is, like I've mentioned so many times already, it's extending the usage hours and improving the overall value of that sports facility. With the artificial lighting, you can easily get depending on where the venue is located, you can easily get 1,000 to 1,500 additional hours of use annually. Let's say with the typical cost of the hour of use, this is a significant increase in revenue for the facility owners. And also one of the big drivers is that our societies are becoming more and more evening active. Our hobbies are turning into a later and later in the daytime. Things inhibiting artificial outdoor lighting, and these are the things that we need to jump over. There's capital and energy costs. Outdoor luminaires are not inexpensive, they are quite costly, and they are high power luminaires. They are consuming quite significant amount of energy, and that energy is considered it's going into more like an amusement, not into a serious business. And therefore it's let's say it's a direct cost, but it's also lots of people are considering it as something that can be cut down the first when we need to start saving on energy. So in order to make outdoor lighting, outdoor sports lighting more socially acceptable, we need to make sure that it's also energy efficient. There is a maintenance, many communal fields, they just are, and best case somebody comes to cut the grass once in a week, but that's all the maintenance they need. When you install luminaires into this kind of field, you also increase the maintenance requirements for that field. Therefore, one of these things, they are kind of inhibitors, but they are also partly drivers. They are pushing, for example, the requirement of maintenance is one of the biggest drivers why all the outdoor lighting is now done with the LEDs, which are significantly lower maintenance than the traditional HIDs. Then resistance from the neighborhood is a big inhibitor. Quite often, if we see a project announced that there's going to be a big stadium, we are also seeing lots of complaints being done to the communal forum about the glare and sky light pollution of these sports lighting fields. But we can always turn many of these inhibitors into drivers, and by designing these things carefully. So with a good design and careful design, we can make the outdoor lighting venues more acceptable. We can make them reduce the glare significantly. We can avoid the overlighting. We can avoid excessive lighting levels, and with the well-focused lighting, with the use of the proper optics, we can limit the visible area of the floodlight, making it significantly more acceptable for the neighborhoods. And in the outdoor sports lighting, the glare especially is one of the biggest reasons for many of these projects getting lots of opposing opinions from the neighborhoods, and there are certain ways of dealing with the glare. To put a little bit of context about what we are dealing with is, I'm sorry about my lousy Photoshop, but I didn't find a good real life example where we would have a communal field with bad lighting and good lighting installed in the same field. For some reason, these just don't exist. But typically what we have is something that we have here on the left. We have lots of very high intensity luminaires on the very tall poles covering wide areas. And because they are mounted on the very tall poles, they are high intensity, they also provide a lot of nuisance light and lots of glare into a neighborhood. We can see the residential buildings behind this field are perfect. The walls are perfectly lit, and this means that there is lots of nuisance light which is also getting into people's windows and distracting their sleep, etc. And on the right we have a really bad Photoshop image of what we should have and what we at LEDiL set as a target when we started to develop a completely new sports lighting optics family. So some of the things that we wanted to address in the neighborhood friendly illumination is that we wanted to maximize the useful light. We wanted to make something which is really energy efficient. We wanted to avoid a glare for the players in that area. And we wanted to minimize the lost light or abusive light, which is the light falling outside the sports venue, which can be divided to a couple of different ways, couple of different portions. We have a spill light, upward spill light, which is participating in the sky glow. Upward spill light is the reason why we don't see any stars in the big cities. And then we have another one equally bad, which is obtrusive light. That is the light which is being distractive, very glary. It also makes your in-use efficacy worse because you are illuminating areas which don't need illumination. And so we wanted to minimize these bad portions of the light. We wanted to maximize the useful light. And in order to do so, we also looked into these ILP, these obtrusive light requirements. And there we have, so this is a way to categorize areas into different zones. We have zones from 0 all the way to 4, where basically 0 and 1 are quite rarely encountered, and you're never going to be able to put any sports venue in these areas. But then we have these areas 3 to 4, which are populated areas and city areas, town areas, where we have limits for the obtrusive light, not only a light intrusion, but also how bright we can see the luminaires. And these were working as a guideline when we were designing the new optics for the sports lighting, which is actually just recently released. We designed this SPORT-2X2 family of optics, where we have 3 different asymmetric light distributions and 3 different symmetrical light distributions. But if you look at these symmetrical light distributions in the polar graphs on the right, you can actually see that they are not perfectly symmetrical. Instead, we have designed them to have a controlled asymmetry, which is helping us to limit glare. And these optics we designed for the 35-35 and 50-50 flat high intensity packages. And they are offering the optimal lighting conditions. You can cover quite vast venues, big venues with these optics. We also wanted to have, we also have very well defined cutoff areas in the light distribution of these optics, so that we can ensure that there is no excessive spill light, for example, on the direction of the spectators. There is no uplight. There is limited uplight, very minimum backlight. Overall, we have very highly efficient optics, which allow you to achieve a very uniform illumination over the wide areas, and you can achieve that with a very good efficiency. Here's one example of what you can achieve with the SPORT-2X2 FT6 or SPORT-2X2 family. This is a football pitch, a standard size communal. So this is like a FIFA Class 2, Class 3 football pitch with the 6 poles around the field. We are in the corner. We have our SPORT-2X2 FT6, which is a very narrow forward throw with a very high candela in the center peak candela, center candela peak, giving us enough punch that we can reach a big distances in the middle of the football field. Then in the center poles we have FT6W, which has still the same 60-degree gamma angle, but now we are covering wider areas on the sideways. And what this optic is doing when used like this compared to together with the FT6 is we are increasing uniformity, and we are achieving a really high uniformity and very low shadowing using the optimal amount of the energy. We are not wasting energy to create any annoying hotspots or something similar in the football field. And this gives us a couple of big advantages over the traditional lighting systems, which usually have really high intensity HIDs and narrow spots. First of all, we have significantly better uniformity, and we can achieve that with the less luminaires and less lumens being used. We can achieve also higher average illuminance. Our minimum and maximum are much closer to the average. We don't have those hotspots in the field, and that makes us very energy efficient. We have very reduced upwards light ratio. Only 1% of the light is above horizon. Overall, the installation is very effective. We are using only 11.5 kilowatts for the illumination of entire football field. And what's very nice for the neighborhood is that if you look at this field from the distance of 140 meters, we have average brightness of any of the luminaires at the 2.5 thousand candelas, and the brightest spot, brightest luminaire is only 9.5 thousand candelas. And this puts us in the pre-curfew E2 environmental class or post-curfew E4. So what it means is that we can have this installation in any we can have this installation in a pre-curfew time in any area, including rural areas where we have just a village and relatively dark outdoor suburban locations. And we can use this post-curfew, that means evening and nighttime, in any small town centers or suburban locations, also in the town city centers with higher levels of nighttime activity. So this basically means that you can, using our SPORT-2X2 optics, you can achieve a feasible installation in almost that you can have installed in almost any place. So it gives you quite a lot of advantage. Of course, we also have lots of other 2x2s. We have our Strata 2x2 family with over 40 different beam patterns. Some of them are here, where we have lots of additional light distributions. Most of these are designed for something else than sports, but there is nobody who is going to say to you that you just cannot use LEDiL Strata 2x2s in the sports lighting. There are quite a few good options which can be also used to complement the sports 2x2 light distributions. Let's say you are illuminating a smaller tennis court, for example, and although FT6W is working perfectly in the tennis courts, you can improve the uniformity by adding a T4B into the same luminaire and modifying the light distribution by combining different optics. So having this Strata 2x2 portfolio available gives you a huge advantage and increases lots of the versatility and gives you a lot more opportunities what can be achieved. Likewise, we also have a high bay beams available in the same industry standard 2x2 form factor, originally created by LEDiL. And in the high bay series, we have beams ranging from 10-degree narrow spot all the way to 100-degree wide batwing type of beam. And again, yes, these are intended for use with the high bays, but there's nobody coming to tell you that no, you cannot use them in the sports lighting. Instead, I could easily think that, for example, HP 2x2 RS, the 10-degree narrow spotlight, can be used to increase the reach of the luminaires, reach of the symmetrical luminaires, and when you need to cover the longer distance. Of course, there are some things that are not optimal because these were not designed for the sports lighting in the same way as Sports 2x2 was designed and really optimized for these sports lighting conditions. One of the things to illustrate a little bit better what we can achieve with the sports optimized optics compared to using, for example, Strata 2x2 FS3, which has been used in the sports lighting a lot. And it was one of the best optics we had for football fields, for example. Here you can see how significantly we have reduced the backlight, for example. So Strata FS3 has typically a little bit over 20% of backlight by design. With the Sport FT6, we have reduced the backlight down to not less than 10%. And this is, of course, because we are reducing backlight. We are not blocking the backlight. We are focusing light more effectively on the field. That is increasing the light on the field. Another big difference why these Sport 2x2s are so unique is if you compare the light distribution on the field of FS3 here on the left against FT6, we can see how FS3 has much more concentrated spot in the middle and a much more concentrated center candela peak, giving you a really high intensity spot in the middle and then having this halo around it. FT6, so this type of spot has it's a good thing because it gives you a possibility, gives you ability to cover longer distance. But on the other hand, if you have a wider spot area, like you have here with the FT6, which is designed to create more uniform illumination over the entire field area, you can achieve significantly better uniformity. And also because we are having a lot less spill light. If you look at the backlight here with the FS3, we have a lot wider area being illuminated compared to FT6. And also because of the good upwards cutoff and lower glare, we are not overshooting the field. If you look at here, FS3 has a lot more light facing upwards compared to FT6. Because we are not wasting light into anything else, this gives us also advantage on the illuminance. So we can achieve, so with these modern optics, we can achieve not only the higher intensity, or not only higher uniformity, but we can also achieve a better intensity and higher illuminance. So that was comparison between old and new Sport 2x2. We have released this Sport 2x2 family a few weeks ago. There is now 6 beams available for the range of different uses, and a couple of new surprises may be brewing, but I'm sorry, I'm not allowed to say much more about those things. Anyway, if you have any questions about Sports 2x2 or others, I think now is about a good time. You have anything?
Thank you, Tero. So the first question is about choosing the right optics for the dialog simulations, in dialog simulations, and how to simulate different lens combinations for a single fixture, like luminar fixture.
Well, on the LEDiL website, there is a measured IES files available for all of the different optics, and you can get that IES file from there. Also, we have our sales and the tech support, which is supporting our sales, that can give you quite a good recommendation on the required optics.
Then there are a couple more questions about Sport 2x2 specifications, about the compatibility for LEDs and the material of the lens.
Okay. So,
yeah.
I'm sorry, I don't see the questions.
About the one pager, if you can go back to the Sport 2x2, it was stating about. Yeah. Okay. So it's from PMMA and.
Yeah, the lenses are made from PMMA, and pardon, what was the question?
What is it made from, and the LED compatibility? What is the size of this? If it was not.
Okay, yeah, sorry, I missed the question there. The lenses are made from PMMA, like already mentioned, and they are optimized for the 35-35 flat packages, and the largest LED that can be fit into this is 50-50. So you can also use it with these now trending 50-50 flat LED packages, such as available for many different vendors. And the lens itself is a standard 2x2, which is not any ingress protected as such. Quite often these luminaires, they have a protective glass which is required for achieving the IP. So yes, you need to put this in the enclosed body. Okay, and then we have a couple of more questions. There is one very good question about when we are showing the results of the lighting calculations. Are we considering that our lenses are integrated inside a product with, for example, protective glass? And yes, we are taking this into consideration. And also, if you go to our website, for many of these lenses, you can actually download the IES file with the protective glass included. So you can also run those simulations by yourself. Then we have one question about how do we simulate different lens combinations in dialogues. Oh yeah, Samuli, now I understand what you were asking. Yeah, so if you need to combine different lenses in a single fixture and you want to simulate the results, there is a freely available software called PhotoView that you can use for combining different IES files, or you can even run that same combination in the dialogues. You can load multiple IES files, and then you define the luminous flux for each of the light distributions so that you can match the portions on how many different lenses you are using for the same luminaire. And then we have one good question asking about the differences between FT6 and FT60. As you can see, there is not much difference over there. The biggest differences between FT6 and FT60 is that they are optimized for the slightly different LEDs. FT60 is giving you a little bit better performance with these 50-50 flat packages, whereas FT6 is much more optimized towards these 35-35 high intensity flat packages. For example, very typical LED is like that is a Nichias NV4 B35 that we so FT6 is giving you better performance with that Nichias B35 part. FT60 is more like a 50-50 platform. Lumileds or Cree available from many different vendors. Then we have one good question. What are the parameters for indoor sports complex lighting and suggestions for lighting uniformity and intensity? These can be found from many different sources, but for indoor facilities, you should be designing the lighting for so that it is taking into account the requirements of pretty much all the games or all the sports that you are being played or planned to be played in that venue. And these requirements you cannot find from each sports association, and then we have some associations which are putting all these in together. Also some building associations, they are summarizing these requirements, but the most precise and important knowledge is available from each sports own association, and there you can find not only these general requirements like here we have for badminton, basketball and volleyball, which are typically just the horizontal illuminance and the minimum uniformity, but what makes this difficult and what you can actually find from these sporting associations are the additional requirements, like for example basketball, you cannot the position of the luminaires and that kind of details, which always have to be taken into account. Okay, I think we have time for one more question. There is a very good question. Anonymous asking, are symmetrical optics more advantageous to asymmetric optics? If yes, in what application? That's a fantastic question. So if we look again at the sports 2x2, we can see we have 3 asymmetric forward throw and 3 symmetrical beams, and there's not a clear advantage. They are just different and they have their own separate advantages. So if we compare asymmetric forward throw to the symmetrical, these both have their own unique use cases. Symmetrical beams, which are these 3 on the right here, they have the advantage being extremely energy efficient, and also the S2 here is capable of covering slightly longer distances than their asymmetric counterparts. They are also, because they are directing most of the light straight forward. They are very suitable for the luminaires for relamping applications. So these kind of retrofit installations where you are replacing the old expensive HID luminaires with the LED counterparts. Then we have another type of luminaire, which is the forward throw asymmetric type of luminaire. These are typically mounted so that the light exit window of the luminaire is parallel to the ground. And this gives them an advantage of having very low uplight. There's basically zero light facing upwards, so they have a significantly lower sky glow compared to the symmetrical ones. On the other hand, they can have higher backlight than symmetricals. They can have they typically have a little bit lower reach than the symmetrical beams. So both of them, they have the different pros and different cons. So depends a little bit on your installation on what can be achieved and what not. Okay, and then we have one last question is coming from Cedric Collard, asking, are these lenses superior to the reflectors like the ones used in design of Forum LED or Citico series? And well, a little bit same thing as with the symmetric asymmetric that we were just discussing. The lenses versus reflectors has the same case. They both have their advantages, they both have their caveats. So difficult to say. I'm not so sure about this. I'm not very familiar with these two luminaires mentioned here, but I think they all are performing well. Lenses typically, they have a slightly better control of the light, and you can do a little bit more, how should I say, complex light distributions, a little bit more complex things with the lens type of optics. Reflectors, on the other hand, quite often have higher efficiency. You can achieve the little bit, let's say, well, a little bit higher efficacy, and also if the reflectors are made from the metal, they have a little bit higher temperature range. So again, apples and oranges, they both have their use, and they are all taste good.
All right, thank you, Tero, for this presentation and all the participants. We had a really great amount of questions, and we will collect all the questions and answers to the recording page afterwards. We will send you the link after this. And it's only my time now to thank you all, and have a great day, evening, and goodbye.
Thank you also from my side, and like Samuli said, there is plenty of questions, so we will try to follow each of these later on the email after this session. Hopefully you all enjoyed. Hopefully something was this was informative. So also from my side, thank you.